Yeah, but what about live transcripts? Oops. There we are, live transcripts. Okay, so I really dislike the first 1 or 2 nights of class because we spend time talking about all kinds of rules and regulations and all kinds of stupid things like that, and we don't really get into math. Tonight, I didn't turn on my recording, but we've been talking about cam scanner and office hours and stuff, but I want to get into math tonight. And this might help you, by the way, on that quiz. When you're solving an equation, or I'm going to say an inequality, emphasis on the in, meaning a not equality. Now, that looks something like, okay, 2x is less than or equal to 6. That's called an inequality. It's not an equal sign, it's a less than symbol. Okay. We mentally pretend that it's an equal sign, and so we divide both sides by 2, because remember, to solve an equation or inequality, we want to get x alone. So when we divide by 2, this becomes x, this becomes 3, this will stay less than or equal. We'll talk about when you flip it another day. All right, this kind of answer, when you say x is less than or equal to 3, like this is known as set builder. And guys, I know that sometimes I write small or sometimes I write messy. So if you can't read my writing, always ask me. Okay, ask me to clear it up. This is known as set builder. Technically, it should be like this. It's real fancy. It's these funny braces, and you say x bar, and then you write x less than or equal to 3. That's the official way. This one that I've circled is the lazy way, but this is the correct way. And I'll explain what all these symbols mean. Okay, but this is the right way to do set builder notation. Okay, now, if we graphed this, okay, we put 0, we put 3, okay, we want to equal 3, so we use a solid dot on it, and we want to be less than 3, so we shade always on the number line, never above it, okay? And we put an arrow there, and everybody's happy. Now, most of you already knew that, okay? When we're trying to solve an inequality, we get our answer, and it's in set builder notation. Okay, this is the lazy way. This is the official way. I'm not going to be real picky about it. And this is its graph. There is a new notation, a new way that's, the math world can't make up its mind. There's a time and a place when this way of indicating an inequality answer is good, and there's a time and a place when this new method is good. And so, unfortunately, what that means for you as a student is you're stuck. You got to learn them both. Okay, so here's the new way. The new way is parentheses, negative infinity, comma 3, bracket. Okay, let's look at that for a second. Okay, this is known as interval notation. An interval is literally a chunk of the number line, interval notation. So one of the key features of interval notation is that what you write mimics exactly what you graphed. So what your graph says is I equal 3, and that's what the bracket is, and I'll show you in a minute. Okay, why that's important. I equal 3, and I shaded all the way down to negative infinity because this graph goes on forever. Okay, and we always input low, comma, high. Whatever the lowest number is goes on the left. Whatever the biggest number is goes on the right. That's called interval notation. Okay, so we have two ways of giving us an answer for an inequality problem. One is called set builder. One is called interval notation. All right, let's try another problem here and see if we make sense. Let's take negative, I don't know, 4x is less than or equal to, oh, I don't know, 16, something like that. I'm going to walk you through it, okay? So the technique is when we do these, we pretend in our own mind that that's just an equal sign. And we say, what would we do? Well, we divide this side by -4 and this side by negative. Oh, wait a minute. I'm sorry. Stop.
Pretty hard to see the, it's pretty hard to see the, what
The
you
red?
just wrote. Yeah.
Okay. Shoot. All right. So we're going to divide this side by -4 and this side by -4. But I want to change the problem here. I don't want it to be less than or equal. I want it to be just less than, because I want to show off something. So I miswrote the problem. Okay. So change your original problem to simply less than. -4x is less than 16. To get x alone, we divide both sides by -4. Divide by -4, divide by -4. This gives us x. This gives us -4 because 16 divided by 4 is 4, and a positive divided by a negative is negative. And then we have a rule. Again, in a couple of days, I'll explain where the rule comes from, but most of you kind of remember it. When you divide both sides by a negative number, you flip the inequality over to whatever it wasn't. So this is a less than symbol. So when you flip it, it becomes a greater than symbol. Okay, but you only do the flip when you divide or multiply both sides by a negative number. Divide by -4, divide by -4. That means I flip the inequality symbol over. Okay, a little bit of math there. So this is our answer. It is set builder. The better way is the set of x bar x greater than -4. But I'm not sure anybody even uses that anymore. That's a fancier, more traditionally correct way. Okay, the graph looks like this. If we graph this, well, okay, 0, oops, 0 is there, -4 is there. Notice I'm not real big on making my graphs perfectly accurate. Okay, you don't have to sit there and go 1, 2, 3, 4. You don't have to make it perfect. You don't have to get your ruler out and measure everything. Kind of show me where 0 is, show me where -4 is. I'm happy. Okay, so anyway, this time x is bigger than -4, but not equal to it. Very, very important. Over here, x could equal 3, so we use the solid dot. Okay, but x cannot equal -4, so to show that, we use an open dot. And that tells everybody that -4 is a key number, but we're not going to hit it. We're going to come so close to it, okay, but never quite touch it. And we want to be greater than, so we shade this way. That would be its graph. Okay, Now, the new notation is, okay, the interval notation for this picture is the lowest one on the graph is -4. The highest on the graph is positive infinity, because remember, you always go low to high, always. But this time, we put a parenthesis on the -4 and a parenthesis on the infinity. Okay, so the big question is, why did you use a bracket here and a parenthesis here? Okay, the bracket is used when we actually touch the number. When we can equal the 3, that's where the bracket comes in. But if you can't touch the number, but you can come close to it, we use a parenthesis. Parenthesis means we came close to -4, but never quite hit it. Notice something else. The infinities, whether they're negative infinity back here or positive infinity up here, the infinities always have a parenthesis because you can never make it to infinity. You can't reach infinity. So infinity has a parenthesis on it always, whether it's positive infinity or negative infinity. If you have an open circle, okay, then you use a parenthesis. And that means you couldn't quite touch the problem. There wasn't an equals there. But if there was an equal, then we have a closed circle and a bracket. All right, questions? You're going to be asked, I know you're asked on the quiz, and as we get further and further into inequalities, you will be asked to do more of this, to sometimes put your answer in set builder and sometimes put your answer in interval notation. You have to read the directions. Okay, even if you got the right answer, let's say you're doing homework in mom and you got the right answer, but the directions said express your answer in interval notation, you have to know how to do that. Okay, now this interval notation is probably new to most of you. The set builder notation, if you've had any kind of algebra in the past before, you've seen that kind of, sort of, maybe. All right, there's a third one here that we get, and we'll see it in future problems, but I want to show it to you right now. Okay. There is a type of problem that comes up with something like this. -2 is less than or equal to x, which is less than 7. Okay. Don't worry about what kind of problem that is. I'll explain it when we get there in about a week or so. Okay, so problems work out to be that. -2 is less than or equal to x, which is less than 7. That literally means, okay, oh, I can't use the red one, can I? Damn it. Okay, that literally means that x is in between the -2 and the 7. So if we looked at this on the graph, okay, we'd have -2, 7, zeros here in the middle. And x is everywhere in between. That's what that says. X is in between those two numbers. But it can equal the -2 because it's less than or equal to -2, but it can't equal the 7. Okay, so this set builder, okay, it's kind of a complex form, but this set builder answer becomes this graph. Okay, and now how do we take this graph and put it into interval notation? Well, again, low to high. Okay, the low number is -2, the high number is 7. Okay, so X is everywhere between that. Okay, I put a bracket on the -2 because it could equal it. That was a solid dot that equaled the bracket. I put a parenthesis on the 7 because it was an open circle and it was not equal. So there's several problems within MOM. They did an explanation of that, but I wanted to make sure that we could do more explanation of that. To make sure you really understood that. Is that okay with everybody? Set builder, interval notation.
Is this, you said this is for mom, so it's not for a homework chapter?
Not yet. It will be. It's for that first quiz in MOM for now. But
Okay.
when we get to really studying inequalities, it's going to be there also.
Okay, good.
Okay.
Okay, and so the first problem, it's the same thing as the last problem we just did, right? It's just the last problem's a little more complex because it has the greater
Yeah.
than equal to. So the way it's explaining it is, so it's always a bracket if it's not quite there, but if it's
No, you got it backwards.
so the -2 is less than or equal to X. X is 0, right?
Well, X is anywhere in between. 0 is just there for a reference.
Okay, so
X
it's less
X is
than.
all this shading.
Okay, and then so you have less than or equal to, so it's right on the 2, but less
hit
than,
the-
okay, gotcha. Okay,
But
so
hit
it's
the
not
2.
quite at 7.
Right. That's it.
Okay, so a solid bracket means spot on, and then the parentheses is kind of like an open circle.
Bingo. You got it.
Got it. Thank you, sir.
Okay. Anybody else? Is that okay? That was better explanation than I gave. Is that okay with everybody?
Mhm.
Again, this is a question that's going to be on, that's in that first quizzy in MOM. It will come back up later. We'll talk more about it later in the future. But
Yeah.
I wanted to talk about that. Yeah, I'm sorry. Go ahead.
No, I think I got it. So the point, you put a bracket with the -2, and then the X is the comma, and then the 7, because it has a 0, 1, it goes to infinity. So you put
Time. There is no infinity in this problem.
I mean, the 0, the ones, the 0 goes over the 7.
Okay. Yeah. The open circle. Because
Yeah,
we can't.
I thought it was a 1 or something in there.
No, I'm sorry. That was just a tick mark on the number line. That was just a space on the number line.
Oh,
Say
okay.
that-
But if you see a 0 there over the 7, then that means you put a parenthesis. I mean,
No parentheses.
parentheses. Yeah. Yeah, I
Right.
think I get it. I
Okay.
got it.
Okay. Yeah. So if you don't touch the number, it's a parenthesis.
Mhm.
If you do touch the number, it's a bracket.
Mhm.
Okay. So over here, we can't touch the -4, and we certainly can't touch infinity. Okay, that's why they both have a parenthesis.
Yeah, understood.
Got it? Okay, cool.
Yeah.
All right.
I have one
would like-
question as well.
Sure, go ahead.
For the first answer, you know how it's 2x, and then the alligator's eating the 6. Is it
Yeah. Okay.
is it always gonna be equal no matter what, or is it gonna
No.
be something else?
Oh, you mean, is it always going to be a pretty number like 3?
No, is it gonna always like you know how you circled it and then put equal?
Oh, that's a mental trick. That's how you think of how do I solve this problem.
Okay.
You
Okay.
you in your mind, you go, I'll pretend it's an equal sign, but I know it's a not. I know it's a less than equal.
Okay.
Okay, that's all that is. Okay. Anybody else? These are great questions. This is what I love. is when you guys get involved and start asking questions. All right, I need to erase. Anybody gonna yell at me?
Just a
Okay.
second.
I
Let me
knew
get
it.
that. I just want to get this one problem.
Okay.
Okay, I got it.
Okay, there's another way I noticed people were doing. Sometimes people like to take pictures on their phone of their screen or of this screen. So
Oh yeah, that's pretty.
that's another
good.
technique I know people have been doing. But
I'm kind of old school.
yeah, me too. I don't think of phones, and yet now I go over to my grandkids' house and what they're doing on their computers, what, the mom hands them the phone, and my God, what they can do. It's just amazing. And I'm just going, and the one kid's only 6 years old, and the girl's 9 years old, and they can do so much. Okay, the next thing I want to talk about a little bit, just a little bit. Again, this is in preparation for the quiz. We'll talk about this later in the future also, again, but I want to kind of load you up now, and then we'll do it again later. It's called a function. A function, okay? A function is a math rule, okay? It's a formula. Now, that's the simplest explanation I could give now. Throughout the semester, and as a matter of fact, throughout your math careers, you're going to come back and continually study functions, and it's going to get much more complicated than what I'm doing today. Okay. Every time we study it, we'll add a little bit extra learning on it, a little bit extra. It'll become a much more complex idea. But right now, a function is a math rule. And we usually do something like this. Okay, there's the rule. And the F is its name. This is the rule F. Now, I just made it up. In 5 minutes, the F rule may be something different. You could have a different rule. We could have G of X equals X squared minus 3X. We just make these up. And the F and the G, or whatever we put here, is simply the name of the rule. This is the F rule. This is the G rule. Okay. And X is its variable. Now, important here. Okay. We say this in English, we say F of X. That's how you say it. I can't write it very well, but that's it. That's how you say it in English, F of X. If you go to your next math class and call it FX, or you call it F times X, nah, okay? The instructor will look at you like, okay, where'd you come from? You say this is F of X. That's how we know it's a function. This would be written as G of X. That's how you say that in English. G of X. It's a function. Now, it's a rule that changes something. So what happens is we're going to ask you something like, what is F of 2? And literally, this is asking you to take 2 and put it in the rule in place of X and do arithmetic. Because look at what we did. We put 2 where the X was. So we're going to put 2 where the X was over here. F of X. X, remember, is a variable. It can stand for anything. So this time I'm saying, I want to put 2 in place of X. So you put 2 in place of X here. You do your work. 6 take away 7 is -1. So we would say f of 2, according to this rule, is worth -1. That's it. It's just a way to do arithmetic. Okay. What about here? G of -4. Try that one. Figure out G of -4. Take a second. G of -4. Anybody think they got an answer?
28.
28? Anybody get a different answer?
Four.
4? Okay. Anybody get a different answer? 28 and 4 are the two most common answers that people get. All right, let's show what this is. Okay. So we're taking
I got
-4.
6.
6? Okay. No, nobody ever gets 6. Never mind, I'm teasing you. Okay. So we're taking -4, put it in place of x. So hang on. This is all of -4 squared. Because this means take all of the x number and square it, all of it. So notice my use of parentheses. Minus 3 times -4. Okay, that's the first step. That's the plug-in. Now, -4 squared, we kind of did this last night. -4 quantity squared means -4 times -4. When you take it to the second power, you multiply it by itself 2 times. So whatever that power is, you multiply it by itself that many times. -4 times 4 is 16. Negative times negative is positive. So this is positive 16. Minus. Now, this is where we really get into trouble. People get all screwed up with minuses and negatives. That was a minus sign. That's still a minus sign. 3 times -4 is -12. But there's still a minus sign right there. Okay, it was a minus sign in the original problem. It's still a minus sign. The -12 came when you multiplied later. All right. We have a rule. Most of you know that what do you do with minus minus? What's the shortcut for minus minus? What's it become?
Positive.
Addition.
Positive positive. Minus minus right in a row becomes positive positive. Okay, so when you have minus minus, it becomes positive. But notice it's later in the problem. You don't do it right away. You get 16 minus -12. Minus negative is positive. So 16 plus 12 is what you have here. So the final answer is 28. Okay. Let's do another one of those, because I'm willing to bet that those negative signs screwed up a lot of people in that.
Yeah, well, what happened with the G minus, -4?
Right.
That is
Like-
just a, okay,
That's what lost me right there too.
okay.
Yeah,
This is just a way of saying in the G function, in this one, you put -4 in place of X. So I put -4 there, and I put -4 there.
So we going off of you making it up too, right?
Oh, yeah.
Okay, right. So you just put
Yeah.
that number there. That was just what you.
Okay, what you're gonna see,
because we're always supposed to like get, like typically it would be like G equals 28.
G
I'm just
of
trying to-
-4 equals 28. G, when I plugged in -4 equals 28.
Okay, so that whole left side of the equal sign just kind of is just the formula
Yes,
that we're plugging in.
yes.
Oh, okay, got it. All right, I was a
Okay.
little lost.
Okay, no problem. What we typically do is like for a test or a quiz, some idiot instructor sits there and makes up problems. I don't know. Something like that. So I just made up these problems. I just made up these functions. F of X, G of X, H of X. Remember, the F, G, and H are just its name. Like if I didn't have a name, you'd have to be saying, hey, you, hey, you. Okay, but now we can say, hey, Larry, and now I know, oh, you're talking to me. So this is the F function, the G function, the H function. So somewhere on the test, okay, somewhere on the test, I might say in problem number 73 on the test, I'm joking, my tests don't have 73 numbers, okay? I want you to find G of -2. Okay, so I've given you these functions for the test, for example, but then I say find G of -2. Well, that's the name. That's telling you, oh, go and look at the G function and put -2 in place of the X and then work it out. So go ahead, give that a try.
So we got what, 1? No, I'm sorry.
Close.
That'd be 17.
Yep.
-17.
-17.
Negative.
Y'all gotta slow down. Y'all too quick.
Okay. So.
Well, I still got it wrong.
Yeah, so G of -2, okay, again, the G is just its name. It tells you where to look. You've got a whole bunch of functions here. Which one do I use? You use the G function because that's what it says. And then it says plug -2 in place of X. So you have 4 times -2 minus 9. Because I put -2 in place of the X. And now you just do arithmetic. 4 times -2 is -8 minus 9. Okay, somebody's got some sound going on in the background there. So-
-17.
Negative who?
-17.
That's correct. Think of this on the number line. You start, here's 0. You start at -8, and then subtraction means lose more. You're starting at -8 and you're losing more. You went to the Del Mar races. You lost 8 on the first race, and then you lost 9 more. Okay, so you lose 9 more. So where are you? You're at -17. So what this says is G of -2 is -17. It's just a math rule. That's all it is. And the G is just its name. It told you which one of these to use. Okay, that's a little bit of function stuff. And mom introduces that early. Okay, I think there's one problem on the quiz, and I think there's a few of those in chapter 1 and chapter 2. I don't know, but I want to get it in there. So that's function stuff. Again, guys, if you get stuck on the homework, okay, those are questions you can email me. Those are questions you can ask during office hours. No problems. Okay, I want to erase, go on to some new stuff. Continuation from yesterday. Can I erase the board?
I'm good.
One quick question,
Yeah.
instructor. So just to recap, can you just put any variable other than 4 there, or how did you, or is it just pertaining to that specific problem?
Where do you see 4?
For number 73. It's so instead of G, like how did you determine,
I just made it up.
oh, okay, all right. All right.
Okay.
Just making sure. All right.
Problem number 72 could have been something like, oh, you guys want me to be real weird? Okay, no, I won't be real weird. Problem number 72 could have been find H of 7. I was gonna get weird on you, but I won't. So I'm just making these up. Where I come from this, I don't know, I just thought of something. So H of 7. Okay. H of 7, I think, is
21.
21. 21. So what's it
21.
say? Yeah, everybody's getting it now. So it says go to the H function and put 7 in place of X everywhere. So 2 times 7 plus 7, the answer was 21. So these are just problems I just made up. Where did I get the numbers? I don't know. My brain just sees these numbers.
Understood. Thank you.
Okay. All right. Like the erase, we doing okay?
Yep. Yeah.
Yeah. All right. Yesterday in class, I talked about PIMDOS. Okay. And I talked, okay, you guys listened, okay, because I talked a lot last night, that P actually stood for to do inside grouping symbols. Oops, if I could spell it, it'd be good. Grouping symbols. And I made a big deal about that and blah, blah, blah. And the grouping symbols that we usually have are parentheses, like 3 times 5 minus 2 or something like that, whatever. But we also talked about how the fraction bar, okay, was a grouping symbol. You get the top, you get the bottom, and only then do you reduce. After the top and bottom become separate problems almost. And reduce. Well, there's another grouping symbol that we use quite a bit, and it's called absolute value. Absolute value. And it looks like this. It's 2 bars. It's like 3 minus 9 with bars around it. So those bars are called the absolute value. The absolute value of 3 minus 9. Now, absolute value, I claim, is like a super grouping symbol. Because not only does it say group, but it does something special at the end. So the first thing we're going to do is we're going to do inside. Okay, 3 take away 9 is -6. Absolute value, -6. But the absolute value symbols, remember I just got through saying there's like super grouping symbols. They take whatever the answer is inside and make it positive. So the absolute value of -6 is regular 6, +6 if you want to put a little plus up there. Whatever is inside the absolute value, it takes it out, no more bars, no more absolute value bars, but your answer is positive. Okay, so let's take something like 15, take away 8.
Real quick. So it will never, so absolute will never have a negative.
The answer, well, hang on, I'm going to try and screw you up in a minute, but yes, the answer will never be negative. Inside, at an intermediate step, you might have a negative, but when you're done with the absolute value, it will be a positive answer.
Okay,
Okay? And
Okay.
as soon as you ask that question, yeah, I'm promising I'm going to screw you up in a minute. Okay?
okay, sounds good.
But you'll see, you'll see. All right, so here we go. Here's another problem. Absolute value of 15, take away 8. Well, again, it's grouping symbols. So we do the 15 take away 8, and we get the absolute value of 7. 15 take away 8 is 7. Okay, but the absolute value makes the answer positive. That's what we were just talking about. So in this case, the answer is still 7. Okay. A lot of people want to change it. If they go, if it's negative, I make it positive. If it's positive, I make it negative. No. The absolute value symbol says your answer to the absolute value part of the problem is always a positive number. Always. Okay. Is that okay with everybody? Because I am going to try and trick you right now. Okay. Now, suppose I had -2 absolute value 3 minus 7. Close absolute value. Okay. Now, PEMDAS says do the grouping symbols. Well, the absolute value is a grouping symbol. So this is -2, absolute value -4. Okay, so you did it inside. 3 take away 7 is -4. But what does the absolute value do? It turns it positive. So this is -2 multiplied by +4. Now, there's two things that go on here. Okay. First off, fundamental idea in all of algebra is when you shove a bunch of things together, they are implied to be multiplication. Does the red show up? Yeah, it does. Okay. So this was -2 multiplied by the answer to the absolute value. -2 multiplied by the answer. -2 multiplied by the +4. So the final answer here is -8 for this problem. Okay. So the discussion over here was the answer to an absolute value is always positive. But something else in the problem might turn it negative. Check it out. Our absolute value was positive when we did our steps. But an extra step in the problem turned it to a negative answer. Are we okay with that or not?
Got you.
Okay.
Is that because the 2 is outside the bracket?
Yep. The 2 has nothing to do with the absolute value. It's just sort of saying, get your answer and then multiply it by -2 later.
Okay.
Okay, everybody? Now, some of you, again, have a strong algebra background. I've seen that, okay? And you know something called the distributive rule, okay? You can never distribute into an absolute value. It's not a parentheses. It's like a parenthesis. It's a grouping symbol, but it's so special. Okay, it has a special property where it turns the answer positive. Because of that, you can't distribute. If you don't know what distributive is or you're not sure, don't worry about it. I'll explain that later. But those of you who know what the distributive is, okay, you can't apply it to the absolute value. Okay. What'll happen is about 50% of the time you'll get the problem totally wrong. 50% of the time you'll get it right. 50% of the time you'll get it wrong. Those aren't good odds. Okay, so it's safer to say never distribute the two inside an absolute value. Do the two later. Do the two last. All right, next. Okay. Oh, I should, for your notes. Okay, I'm sorry. This absolute value discussion, this is chapter 1.3. I should have put that up there. I'm sorry. It's in section 1.3 that absolute value comes up. Okay. So I'll leave that for a second. Okay, now I'm only hitting the highlights of what I think students struggle with in chapters 1 and chapter 2. I'm only hitting the highlights. If you find out in your homework that I haven't taught you something or you want extra help on something, that's when you ask. Okay, you yell and scream at me and say, hey, I don't get this. In chapter 1.4, okay, chapter 1.4, the confusion, we did this last night. First off, we want to talk about exponents. So when we write like 3 to the 4th power, okay, the 3 is called the base. That show up pretty much. Okay, the 4 is called the power. Okay, and what it means is 3 multiplied by itself for a total of 4 times. So exponents actually just mean multiplication. When you do an exponent, 3 to the 4th power, okay, the base is 3, the power is 4, 3 times itself 4 times. You multiply it out, your calculator, whatever you have, and you get this answer is 81. Depending on the calculator you have, okay, some calculators use this, so you could go on your calculator 3 up caret 4. Okay, that would be 3 to the 4th power. Some calculators have that button on your calculator. The TI 36, let me make sure. Okay. It's got 2 buttons. The TI 86, it's got an X box button. So you would say 2, you would hit the X box button 4, and what it's doing is going to put that 4 into there. Okay, it's going to be 2 to the 4th power. That's what that's going to show up as. Again, you're going to have to play with that a little bit, but the 36X Pro uses that button for weird powers. Other calculators use that button. Okay, you can find that. You could play with that on your own. That's not real critical right now. this getting comfortable with powers, we're going to have a whole chapter later on dedicated only to exponents. We're going to have positive exponents, negative exponents, fraction exponents, decimal exponents. Okay, we're going to have a whole chapter dedicated to all of those exponents, but they all start with this idea. What is an exponent? What's the base? What's the power? What does it mean? They all start with that idea. Okay. And by the way, those of you who've long time ago took intermediate algebra, probably the thing that eventually killed everybody was something called logarithms. If you've ever heard of that, that's based on exponents. So when we get to exponents, you really and start getting in deeper and deeper, you need to dig in. Okay, that's a whole chapter and a whole other chapter based on exponents. So we got exponents. One of the things I did last night, okay, is I asked the question, what's the difference between -5 to the second power versus -5 to the second power? That's going to be a that type of problem. That problem, almost exactly that one, will show up on. I made sure it'll show up on the chapter 1 quiz, and I made sure that it'll show up on exam number 1. Okay, check your calendars for those. And we did this last night. One of these is 25, and one of these is -25.
The first one is -25
Why?
because we don't touch the minus if it's not inside the exponents.
Good. Okay. What I heard you say was over here, the minus is being affected by the power, the exponent. So the whole thing is being powered. This is -5 multiplied by -5 because the negative is being affected by the power of 2. So negative times negative is positive. 5 times 5 is 25. But here, this negative is not being affected by the power. So this is technically -5 times 5. So 5 times 5 is 25. Answer -25 or -25 like that. Here, only the 5 is being affected by the power, not the negative sign. So that's one thing we did last night. I know that shows up in Mom a lot. I know it does. Okay.
So basically, it's kind of as if there was a parentheses between the negative sign and the 5 squared, correct?
Yes. Or, okay. We can come back to PEMDAS. Let's say I wrote that. This is actually the negative sign means -1 times 5 to the second power. See, math is big on shortcuts. Mathematicians are inherently lazy. Okay, we don't want to write 1x. Oh no, we're too sophisticated for that. We're just going to say x. Okay, we don't want to write x to the first power. We're just going to say x. We don't want to write -1 times 3. No, we're going to call that -3. Because mathematicians are lazy. The least number of symbols necessary to express our idea is what we like as mathematicians. The problem with that is mathematicians understand it, but students don't. Okay, students, mathematicians go, well, yeah, everybody knows that. Well, no, not everybody knows that. But when you write -5 squared, you're saying -1 times 5 squared. The negative means -1 times somebody. And so you use PEMDAS, you use exponents first. So this is -1 times 25, which is -25. That's a different way of looking at it than I showed earlier, but it's saying the same thing you just said. Okay, and a lot of this, guys, a lot of this semester is me explaining how mathematicians are just lazy. There's so much mathematicians do that we assume the whole rest of the world understands. Okay, and that ain't the case. Okay. That was exponents. Chapter 1.4 was all about exponents. That's the basic idea. I promise question like one of these on the quiz, chapter 1-2 quiz, and I promise one of these on exam number 1. I promise that. Okay, seeing if you can pay attention to the subtleties, to the use of parentheses or no parentheses. Okay, chapter 1.6, we're skipping 1.5, there's no assignments there. Chapter 1.6, fractions. Okay. Always reduce. Always. Okay, I can't stress that enough. Now, there's some confusion. When you reduce a fraction, let's take 6/8. Okay, technically, you're saying this is 2 times 3 and this is 2 times 4. Mentally, this is what you're thinking. You're saying, oh, 6 is 2 times 3, 8 is 2 times 4. These two twosies cancel out, and so we get an answer of 3/4. Yay, we're done. Okay. However, a lot of us have learned that if I divide the top by 2 and the bottom by 2, as long as I divide the top and bottom by the same number, I will still get 3/4. Now, on your calculator, on the TI-36X, okay, where did it go? Oh, right above the 7. You have a 7 key, and then there's something here, and then you have a bracket over on box over box key. So on your calculator on your 36X, okay, above the 7, you have that. Other calculators, other scientific calculators have something similar to it. Don't worry about it. And you don't need your calculator now. So relax, you have all weekend to worry about it. If you press that, you can fill in, if you hit that, you can fill in your fraction 6, 8, and it will automatically, when you press the equal sign, it will automatically reduce it to 3/4, automatically for you. Okay. So all calculators, all scientific calculators have this fraction button. And when we get more and more complicated problems, I'll show you how to do more. There's a button, I think it's on this one right above the 7. Where's my, okay. Is it above the 7? Yeah. Right above the 7. So we're all going to be, okay. So you have your 7 button, and then right above it, you got this. Okay, here. Okay. And that number will allow you to put in 3 2/3. You can put in mixed numbers. That button will allow you to do that. Okay, just play with it. How do you activate that button? You have to go second. You have a second key and then the 7. That button will be activated and you can use your arrows to input that. Then you never have to worry about adding, subtracting, multiplying, or dividing fractions because your calculator will do it for you. Once you learn how to input using that button, which is right second 7, okay, on your calculator, you can add, subtract, multiply, divide, reduce, everything. And you don't have to worry about common denominators and all that other junk that always screwed you over in math. Okay, if you don't have a TI, look for this button. It does the same thing. You're gonna have to play with it a little bit, but if you've got that button, you can input a fraction. And then once you've inputted it, you can multiply it by another fraction, divide it with another fraction, add it with another fraction. It'll find common denominators for you all the time. Make sure you have your calculator with you during a test. It will save your rear end. Okay, no more problems with fractions. If you can't figure out how to use it, okay, we can take some time tomorrow to play with it a little bit, show you how to use either of these buttons. Okay, back to reducing fractions. Back to reducing fractions. Okay. When I said you must reduce, but students get confused, okay, between reducing versus simplifying. Reducing versus simplifying. Way back in grade school, they told you, oh, no. You can't have a top-heavy fraction. You can't do that. That's bad. Well, nobody cares about those anymore. But we do care about is that this will reduce. You could divide the top by 3 and the bottom by 3. Top and bottom can be divided by 3. And because of that, 12 divided by 3 is 4. 9 divided by 3 is 3. That is an okay answer. It's an acceptable answer. Yes, it's top heavy, or actually technically it's called improper. But we accept it. 100% we accept it. It stands for 1 1/3. How do we get that? We divide 3 into 4. 3 goes into 4 one time. 1 times 3 is 3. Subtract, we get 1. So it went 1 whole time. And this is the remainder. Okay. So that's what the 1 whole, and that's the remainder up there. If you had 18 fourths, again, it's top heavy, but it more important than that, it needs to be reduced. We can divide top and bottom by 2. 2 goes into each of these. So this becomes 9 over 2. That is 100% acceptable. I'll take it every day, all day, because you've reduced it. Now, if you want to simplify it further, okay, and divide 2 into 9, go right ahead. That's okay. 2 goes into 9 4 times. 4 times 2 is 8. Subtract, we get 1. So it is 4 whole times and 1 out of 2 left over. And by the way, your calculator will do that. Your calculator will change it from that number to that number. It's a little bit trickier. But what I want to talk about in section 1.6 is when you see a fraction, you always attempt to reduce it. But you can leave it top heavy. There's a difference. Reducing means making your numbers smaller. Dividing top and bottom by the same amount. Always it's got to be the same amount. Reducing is dividing top and bottom by the same amount. And you can leave your fractions top heavy or improper. Fine with me. And I'm pretty sure it's fine with Mom. Okay, I can't recall if there's an issue with that. Okay, two more things I want to cover in chapter 1. Then we'll take a break. When we come back after break, we'll start chapter 2. Okay, two more things. Again, I'm hitting the highlights. If you get into your homework and you think you need more instruction, that's where you email me or that's where you talk to me during office hours. But with fractions, always reduce them. You guys are going to get real pissed at me on tests because I will take points away for non-reduced fractions. Okay, a couple more ideas. Okay. We already talked about chapter 7. We talked about rounding. Again, you'll be able to use your calculator for any arithmetic at all. So don't worry about adding or subtracting or dividing or multiplying decimals. Don't sweat that at all. You have your calculator. Just don't forget it for a test or a quiz in class. Okay. Chapter 1.8. Has a bunch of just a bunch of silly rules. Okay, it talks about the real numbers, and that's a group of numbers. That's everything on the number line. Everything on a number line. Everything. It's all the fractions, all the decimals, all the whole numbers, all the negative numbers, anything you can think of, including all the square roots and cube roots and all the other things. Real numbers is our term for every number you can conceive of. Okay, so you'll see a lot when you read the problems you talk about. You'll see the phrase X is a real number. That means it's everything that you can find on a number line. Any number that you can find. Pi is a real number. It's on the number line somewhere. Okay, the square root of 7 is on the number line somewhere. Okay, so that's kind of boring. So math wants to classify things. Math wants to break things down so we can put them into smaller groups. You know, girls and boys, tall and short. We want to categorize people. We want to put people into holes so we can discuss them or describe them better. So the real numbers are made up of two parts. They're made up of rational numbers, and they're made up of irrational numbers. Now, rational numbers are in any integer divided by integer. Integer divided by an integer. 7 divided by 3. Okay, 15 divided by -9. Any integer divided by another integer, with the exception that the denominator cannot be 0. Whatever else, the denominator can't be 0. 127 divided by 532. If you have an integer divided by another integer, just a basic number, positive, negative, divided by itself, that's called a rational. Now, they have certain properties. Their decimal, okay, either terminates or it repeats. So let's take an example. 3/4. If you pop that into your calculator, or if you know what it is, it's 0.75. 3/4 as a decimal is 0.75. This is called a terminating decimal because it stops. When something terminates, it ends. So this is a terminating decimal because it stopped. Okay. But we also have seen something like 2/3. That's still a rational number because it's still a normal integer divided by a normal integer, no problem. But when you look at its decimal on your calculator, you get this point, and then you get a whole bunch of 6s. Okay. And this is called a repeating decimal. It never stops, but it repeats a pattern. And when it does that, okay, we put a bar over the part of it that repeats. And we know that both of those are called rational numbers. Their decimal either terminated or their decimal repeated. So anything you can think of that's nice and pretty is pretty much a rational number. Now we come to, okay, well then what's irrational? Okay, my mother actually, very irrational, but that's another story. Okay, but pi is irrational. Any square root that doesn't work out pretty. Let's come back over here. The square root of 16 works out to be a nice pretty 4. So that's a rational number because it's 4/1. So it's an integer divided by an integer. So there are pretty square roots, square root of 16, nice ones, but then there are ugly square roots. Okay, same thing. There are something you don't know about yet, maybe, but there are cube roots, and there are fourth roots, and there are fifth roots. Okay, there are all kinds of bizarre numbers. And what all of these have in common, okay, is their decimal, okay, never ends, and there's no pattern. My end of the, okay, I'm not, PTERN. Come on, Foster. No pattern. So when you look at these on your calculator, if you have your calculator or your computer or something at home and you type in pi, Okay, we know, okay, we use pi all the time. We say, well, pi is 3.14. No, it's not. That's just we're lazy. Pi goes on 3.1415. I think it's 79, something. It goes on forever and ever and ever and never repeats a pattern. Ever. Same thing with any ugly square root. You put it in your calculator, okay? It goes on, the decimal goes on forever and ever and ever, and there's no pattern to it. So those are called irrational numbers. Irrational numbers. So the real numbers are broken up into two major categories. One is called rational, the other called irrational. So you need that vocabulary. We're going to be working with both of these ideas throughout the semester. Okay. There is one important thing here. For square roots are actually, well, okay, we'll stick with square roots for now. For a square root, okay, when you do the square root of somebody, the inside has to be greater than or equal to 0. What that means is the inside has to be positive, basically. And the answer is always positive. I get out of the way. For a square root, the inside the square root has to be greater than or possibly equal to 0. You have a square root button on your calculator, hit the square root of 0, you'll get 0. Okay? Put in any number you want, you'll get a positive answer. What you won't get, if you put in a negative number like -3, if you put in the square root of a negative number, you're going to get an error on your calculator. That's impossible. It does not exist. Okay, DNE, I think is the abbreviation Mom lets you use. So this is a fundamental rule, okay, for square roots. The inside of a square root has to be a positive number or 0. Has to be. The answer is always positive in a square root. Okay. If you ever end up with a square root of a negative number, you'll get an error on your calculator. I mean, try it. If you have your calculator there, even your cell phone or something, you have a calculator on your cell phone. Right now, I don't care what you use at home. Okay. You should get an error. It should say something like error or domain error or danger, Will Robinson, something's bad. So that's really important. You're going to run into that. Mom is going to hit you with that a couple times to see if you're paying attention. There's rational, there's irrational, and then there's does not exist. Remember, the rational and the irrational are part of the reals. They're on the entire number line. Somewhere, all of these are on the number line somewhere. Okay? The square root of a negative, is no place. It doesn't exist. It's not on the number line, ever. So be aware of that. You'll get caught a few times. And then you'll pick it up. All right, one more topic, then we take a break. One more topic, then we'll take a break. Chapter 1.9. in chapter 1.9, okay, we're getting close to some algebra. So far, everything I've been talking about has been arithmetic, just some basic number theory, some arithmetic. We're going to get real close to some algebra. The first thing we want to talk about in chapter 1.9 is called like terms. Okay, like terms have exactly same variable. So 3x plus 7x, these are called like terms because they both have x's. And so what we do is we add the 3 plus the 7 and stick the x at the end, which we get 10x. So when you see like terms, okay, they have exactly the same variable. We add what's called their coefficient, the number in front, 3 plus 7. Now, nobody does this, but everybody thinks it. When you have like terms, you add the coefficients and stick the variable on. Okay, how about 5x minus 3y plus 7 minus 2x minus 9 minus 5y. Whew. 5x minus 3y plus 7 minus 2x minus 9 minus 5y. There's all kinds of like terms here. For example, there's the 5x and the minus 2x. There's the minus 3y and the minus 5y. And there's the 7 minus the 9. So we have the like terms of x, the like terms of y, and the like terms of just ordinary numbers. Okay, that's what you kind of have to see. Now, I don't care if you write it down this way. If you can scan the problem and just go, oh, I have 5x, take away 2x, so I have 3 x's. If you could jump to that, I'm happy. That's cool. And I have negative 3y or negative 3y, take away 5y. Now think about it. You're a yak farmer. You lost 3 yaks, and then you lost 5 more yaks. So what have you done? You've lost minus 8 yaks. Minus 3 minus 5 is minus 8 y's or yaks. And over here, 7 take away 9 is a minus 2. If you can jump to that in your head, there's no reason for you to have to write this down. You had to see this mentally. Mentally, you had to see the like terms, but you don't have to write them down. That would be the final answer for that problem. Is that okay for like terms, kind of, sort of? Anybody? That's okay?
Yeah, that's good. That's good.
All right. By the way, it doesn't matter how you scramble these numbers around. Okay. There's no rule for who goes first and who goes second. If you want the 8y to go first, that's cool, but you got to keep the minus with it. And if you want the minus 2 to go in the middle, that's great. You can put it there, but the minus 6 with it. Now, what's wrong with this? Look what I just wrote down here. I scrambled the answers up, the variables up. I put the minus 8y in front, the minus 2 in the middle, and I put the 3x in the end. But that's wrong. Why?
You need
Now you have to multiply.
Well, that says multiply, but were they really multiplying up here?
Negative.
Okay. So what do I need? I heard somebody start to say I need something.
you
I
need the
knew it.
plus sign.
Yeah, remember, math is lazy again. There's an implied plus sign on the 3. Okay, which we don't write because we're mathematicians, because we're lazy. But when you move these around, the plus sign goes with it. So you had to put it there as a +3. That separates them out. Okay. Do I need to talk about distributive? Now I'll do that next. Let's take a 10-minute break, 8:25. Come back here at 8:25. Okay, we'll talk a little bit about chapter 2 and then go home early tonight. Okay,
Got it.
I'm gonna go get a drink of water, 8:25. Somebody remind me. Okay. We'll see how far we get. We're going to start with chapter 2 now. And chapter 2 is all about solving equations. And we need to talk a little bit about a philosophy. Okay, because if you solving equations is more than just a bunch of dumb rules, although I am going to give you some dumb rules either tonight or tomorrow. But the rules make sense if you understand the philosophy. An equation represents balance. So when we write an equation, think of a balance beam. It's being balanced and it's perfectly balanced. When we write an equation, it's perfectly balanced, no matter how ugly we write it. 2 parentheses 3x minus 7 plus 9 equals 3. Okay, your eye says, oh, the left side is bigger than the right side. That doesn't matter, because an equation represents balance. This thing is perfectly balanced, and we can never do anything to unbalance it. Okay, that's why we have this rule where we say anything you do to one side of the equation, you must do to the other side. So if you add 7 to one side, you have to add 7 to the other side to keep it balanced. If you divide one side by 9, you have to divide the other side by 9 to keep it balanced. So an equation represents balance. Okay, that's the key thing. And we have this fundamental rule that says any arithmetic you do to one side, you have to do to the other. Addition, subtraction, multiplication, division. The next thing is an equation is a search for truth. Believe it or not. Eventually, when you solve an equation, your goal is to get X alone. You get X alone. And when you do, you get something like X equals 3 or something like that. What that implies is that 3, if you plug it into this problem in place of x equals 3, assuming you did all the rules correctly and didn't screw up or anything like that, 3 makes the left side equal to the right side. Now, I have no idea. I just made up this 3. Don't worry about it. Okay. But when we get x alone, when we're done, we're telling the world that if I plug 3 in place of x up here, the left side will equal the right side. That's called the truth. So the first thing you're going to see in chapter 2, Mom, is they're going to give you an equation, 2x minus 7 equals 4, something like that. And they're going to ask, is 2 a solution? Something like this. And what they're saying is if you plug in 2, does it make this problem true? And so it's real simple. You just plug 2 in place of x. This implies to be a solution. That means x equals 2. So you go 2 times this 2 minus 7. Does it equal question mark 4? Okay, now, some of you can do all this in your head. Great. Some of you need to do it on scratch paper. Fine, no problem. But when we're saying 2 is a solution, you're telling the world that if I plug in 2, it will make the problem true. So 2 times 2 is 4. Take away 7. Does it equal question mark 4? The minute you know it doesn't, you can quit. You don't have to finish the problem. The minute you know, okay, there's no way those two are the same. But if you want to finish it, 4 take away 7 is -3. -3 certainly doesn't equal 4. So is 2 a solution? Not in this problem. No. A solution makes it true. A solution means when you plug that answer in, what you think is your answer, into the original problem, the left side will equal the right side. So at the beginning of chapter 2 in like 2.1 or whatever, Mom has a bunch of problems. She gives you an equation and they start out simple and they get uglier and uglier. And she just says, is 2 a solution? Is 5 a solution? Is 9 a solution? Okay, and all you're doing is plugging those numbers in and seeing, does it make it true or false at the end? That's all you're doing. So back over here, when I said when we're solving an equation, it's a search for truth. We're looking for the value of x that when I plug in makes the problem true. Okay, there's 2 ways we can do this. One is you can just start guessing at numbers. Oh, you say, hey, for this problem, x is 9. No, maybe it's 3, and then go check it. Oh, maybe it's a half and check it. Or you can memorize some steps that are guaranteed to give you the solution. So you have 2 possibilities. If you want to solve this and find the solution, you can either guess, okay, which means you might be there forever, because when I make up problems, my answers, well, when I do problems on the test, my answers are like 3/7. You'd guess all day before you came up with 3/7 as a guess. Okay, so when I build test questions, I build them to make sure that you understand what the steps are, what the rules are, and that you can't just guess randomly at something and maybe get it right. Okay. So There's some fundamental ideas that we start with. And over here, back when I said, because it's balanced, we have to do the same thing to each side. We have some basic ideas. Addition, which I circle, and subtraction, I circle them so they stand out. They always cancel each other. They cancel. This is a fundamental idea. Multiplication and division always cancel each other. They undo the effects of each other. Let's say you had 7 and you multiplied it by 3 and then you divided it by 3. Okay, 7 times 3 is 21. Divided by 3 gives back 7. So what this is an example of, what you're supposed to look at and go, ooh, I understand now. Even if you don't, you go, ooh, I understand now. Okay, is that when you multiply by 3 and then later divide by 3, you cancel everything out. They all cancel each other out, and you end up with what you started with. Same thing with, let's say I had 5 minus 9 plus 9. Okay, well, the minus 9 and plus 9 cancel each other out. 5 take away 9 is -4, plus 9 is 5. Again, a simple example that shows that subtraction and addition of the same number always cancels each other out. Okay, so we're going to use all of these ideas in our equations. Okay, we're going to use the idea of balance, truth, and we're going to do some problems. And also the idea that addition, subtraction, multiplication, division cancel each other out. So we're going to use all of those. The problems in MOM all kind of run together. So I can't tell you this is chapter 2.1 and 2.2. They all just kind of run into each other. They're all doing the same thing over and over. But let's take a problem, for example, like 3x minus 9 equals, I don't know, I guess I'll be nice to you today, 6. Okay. Our goal is to get x alone. Well, the first thing we undo, the first thing we look for is addition or subtraction. Okay, so we want to get rid of the 9, but it's a minus 9. Because again, the goal is to get x all by itself. So we need to strip away the 3. We need to strip away the 9. We need to get rid of them. The only way to get rid of a minus 9 is with a plus 9 to both sides. Okay, now I'm going to ask this question over the next couple of days, so get used to it. Look where I'm pointing. What is the purpose of this 9 on this side of the equation?
Cross cancel.
Okay, cancel out this 9, not cross cancel. Cross means over the equal sign.
Yeah.
But
Sorry about that. Yeah,
cross
cancel it out.
that's okay, no problem. Okay, but wait, then what's the purpose of this 9?
Because you have to do everything in balance, right?
Balance, good. So it looks like some bozo just put 9 and 9 up on each side. Well, we did, but we did it for 2 totally different reasons. This positive 9 and this negative 9 will cancel each other out. That's their purpose. This 9 over here was to keep the problem balanced. So when we do that, we end up with 3x. The 9s cancel each other out. Technically, there's a plus 0 there, but nobody ever writes the 0. So we get 3x equals 15. Okay. Notice solving an equation is working down, trying to keep the equal signs lined up. All right, now we look at this as a whole new problem. Okay, I need to get rid of the 3. But what's it doing to the x? And this is where, again, mathematicians are nuts. When we say 3x, did the times come through? We mean 3 times x. Can you guys see that times or not? Is that showing up?
Yeah.
So the
Yeah.
only way to cancel out multiplication is with division. Okay. And you divide this side, same thing both sides. Again, what's the purpose of, look where I'm pointing, this 3? What's the purpose of this 3?
To get the x alone.
Yeah, it'll cancel out the other 3 with the x. So technically, 3 divided by 3 is 1x. And then we go, well, that's stupid. Let's just write x. Okay. But yeah, to get the x alone, look where I'm pointing. What's the purpose of this 3?
Divide.
To balance.
To balance. You're going to divide, but why did I stick a 3 up there? Why did I put a 5? Why didn't I put a 7? For balance. So this, the equal sign comes straight down. This is 5. This is our solution. So we could check our work by plugging it back in. Okay, in fact, we should. If I take 5, put it in here, is 3 times 5 minus 9. Does it equal question mark 6? Because to be a solution means when I plug it in, it makes the problem true. So that's 15, take away 9. Does it equal 6? And again, you need to do just enough work to ensure that yes, it is a solution or no, it's not. I don't care. So yes, it is. That's it. We're done. Notice here, in most equations, the first thing we attack is any pluses and minuses. We go after them first. We get rid of a plus or minus. Like here, I had a -9 with the x, so I attacked it first. I got rid of the -9 with a +9. The second thing we attack was the multiplication or the division. So after I got rid of the -9, then I got rid of the multiply by 3. The order that you do that is very, very important, guys. You can't do these out of order. You can't say, oh, I want to divide everybody by 3 first. Well, in this problem, it actually works. But in another problem, well, no. Attack the plus or the minus first, get rid of all the pluses and minuses, then get rid of either the multiplication or division. Okay, so okay. X over 2 plus 5 equals -1. Do you want me to let you guys try that for a second? Attack the +5 first, then attack the divided by 2 second. Let's pause for just a second while you guys work on that. No. Okay. Crap.
So we're good to go?
You're good to go.
All right, thank you, sir.
Adios, everybody.
Bye-bye.
Good night.
Question, instructor.
Yeah.
Are the videos usually available next day or?